For our second example, we're going to look at a subset W that contains some elements in R2, and the requirement here is that x1 plus x2 is equal to 2. So let's go through our verification process. But pretty quickly, I think if we note that x1 equals 0 and x2 equals 0, that this is not in the set. Now that doesn't necessarily mean that this isn't going to be a subspace, because our check for 0, 0 being in the set is really a condition about whether or not the set is empty or not, which we can see that the set is clearly not empty since it contains a line. So we may not have a problem here. It just turns out that in this case, 0, 0 is not in the set. But it might be an indication that there could be some problems down the road for us. So let's go ahead and start working the second part of this, which is our closure under vector addition. And we'll take our generalized vector u in R2. So this is going to be u1 and u2. And we'll take our generalized vector v, which is going to just be v1 and v2. And we need to impose the conditions that are provided, which is that x1 plus x2 equals 2. We can solve this either way. We can either solve it for x1 or x2. It doesn't really matter. I'll go ahead and just say that x2 is going to be 2 minus x1 as our condition. And that means that u1 will take the form, or rather u will take the form u1, and u2 will be 2 minus the first element u1. And the vector v will take the form v1 and then 2 minus v1. And as we did before, we'll go ahead and add those two things together and try and show that they're in the set. So we take u plus v, and that's going to look like u1 plus v1. And the second element is going to be 2 minus u1 plus 2 minus v1. Again, let's be detailed, write out every little step on these ones. And we get u1 plus v1. And then when we simplify here, we end up with 4 minus u1 plus v1. And again, we see we've got a problem here because now instead of having 2 minus the first element, the second element is 4 minus the first element. So this shows that it's not in our set W. So now we've got something that is definitely not going to be a subspace. And just for the fun of it, I'm going to go ahead and work through the third condition just so we see what happens with that and get the practice for it as well. So again, this is our scalar times our vector u. So here that would look like a times u1 and a times 2 minus v1, or u1 rather. And again, we've got to be able to manipulate this to make it look like it belongs in W. So AU1, and I better have 2 minus AU1, the second element. But when we do our distribution, I get 2A minus AU1. And once again, we see that we don't get the appropriate requirement that this be 2 minus the first element here. So again, it's not closed under scalar multiplication. So I think it's good to see where these things fail so we know what to expect when we're working through them. But again, it's important that we work through every little detail here to make sure that we get it correct. So this one that we've started with here, this will not be a subspace. And I want to just re-emphasize the point here that just because condition 1 was not met did not necessarily preclude it from being a subspace. It just might be an indication that maybe there's something wrong there. But we have to continue on in the process anyway. This condition 1 is really to ensure that the set is not empty.